Hello, today we are going to learn about momentum. Okay, so this is our new unit that we're about to start. And so let's go ahead and get started. So, momentum. What is momentum? When we think about momentum in a normal sense, just like an everyday sense, we think of it's like being able to continue moving forward, right? Like maybe you start scoring well in a class and you have this momentum that carries forward. Well, in physics, we kind of have a similar idea, okay? So, momentum is sort of mass's ability to continue moving forward. Okay? So it's just this idea of the more momentum you have, when you hit something else, you're more likely to continue moving forward. Okay? So the formula for this is just going to be P equals m times v. Okay? So there's two main things that this is dependent on, right? If I am going to run into something, right? The two things that's going to help me continue moving forward is how fast I'm moving, right? The faster I'm moving, the more likely I am to continue moving forward. And the second thing is how much mass I have, right? The bigger I am, the more I'm going to be able to knock something over, correct? So momentum is mass times velocity. You notice it's very similar to our kinetic energy formula, right? But it's a little bit different. Velocity and mass have sort of the same amount of importance, whereas in kinetic energy, the velocity was more important. Okay? So let's just go through this. P stands for momentum. Okay? M stands for the mass. And what are the units for mass, everyone? That is right, kg. Okay? V stands for what? Velocity, yes. And what are the units for velocity again? Yes, of course, meters per second. Thanks for answering back to your video, by the way. That might be a little bit odd, but it helps you think through the ideas. Okay, so now we look at this. If I have kg, and then this one is meters per second, so the units for momentum are just kg meters per second. Okay, there's no sort of abbreviation for momentum. I will also let you know another way to abbreviate this is newtons times seconds. Okay, so there's two different ways to do that. Okay, so that takes care of our units. Now let's look at scalar or vector. Okay, so let's go through this piece by piece. Okay, momentum is equal to mass times velocity. Mass. Is this a scalar or a vector? Of course, right? Mass is a scalar, right? No direction. Okay? Now, velocity. Does velocity have a direction? Yes, velocity has a direction, so it is a vector. Okay? Now, if I take a vector, so for example, 5 meters per second north, right? That's a vector. I got a number and I got a direction. If I multiply this by a number times 10, is this going to give me a scalar or a vector? Well, that should give me another vector, right? So I just multiply the numbers, direction stays the same. So, momentum is a vector. Okay? So in momentum, the direction is going to matter. Remember, going back to energy, we didn't need to worry about the direction, but for momentum, we will need to worry about the direction. So for these problems, if they give you a direction, you need to make sure you leave that direction in the answer. Okay? So direction is going to be quite important in momentum. Okay, so now let's look at this example problem. We have a 2,250 kg pickup truck, and it has a velocity of 25 meters per second to the east. What is the momentum of the truck? So let's go ahead and define our variables like we normally do. Okay. So what is our mass? Yes, that's correct. Our mass is 2,250 kg. Okay. And what is our velocity? Yes, that's correct, right? Our velocity is this 25 meters per second to the east. Okay. Now remember when we did kinematics and we needed to worry about our axes? I would say again in momentum this is something we need to worry about. Okay. If we only have one direction, it's not going to matter as much. But when we start having multiple different directions, it is going to matter. So let's go ahead and set our axes. East is usually positive. Let's make that positive and negative. Okay? So not too bad. This is a positive because it's to the east. Now, what formula do you think we're going to use? Yeah, the formula we probably should use is let's go ahead and use the formula we just learned. Okay? So I got P, my momentum, is equal to mass times velocity. Okay? So I have P equals 2,250 times 25. Okay, now here is the part of the show where you take out your calculator and you type some numbers in, okay, and get this answer. Okay? So go ahead and pause the video, get that answer. Okay, now that you've gotten that answer, what were the units that we use for momentum? I'll give you a second to see if you can find it. Yes, that is correct, kg meters per second. If you wrote newtons times seconds, that would also be correct. So either one of those is correct, okay? Usually we use this for momentum and this for something else that I'll teach you in a little bit, okay? Now, what I want you to do is go ahead and look at that first problem. So let me scroll up from set A, okay? So this first problem from set A says can a bullet have the same momentum as a truck? Okay? I want you to go ahead, take out your piece of paper that you're going to be answering these questions with, okay? And I want you to see if you can come up with the correct answer for this question, okay? I'll go ahead and give you a second to pause the video, and then I'll explain the correct answer, okay? So go ahead and pause your video and answer this first question. Okay, so hopefully you got an answer to this. Now, can a bullet have the same momentum as a truck? Now, here's one easy way, okay? What if the velocity of the truck is 0? What's the momentum? Well, if I have my momentum is equal to m times v, if v is 0, my momentum also needs to be 0, right? Okay? But if I have a bullet and its velocity is 0, what will its momentum be? Exactly. It will also be 0. Okay? So that's one easy way. The other way is if I have a very high velocity for my bullet, because it has a small mass, and then my truck has a very big mass and a very small velocity. Okay? So there's two different ways that you can have them have the same momentum. One is the easy way, they both have a velocity of 0. The other way is if I have a bullet with a small mass having a large velocity, and then my truck with a large mass has a very small velocity, okay? But they can have the same velocity. Go ahead and work on finishing these questions. Make sure if you have any question that you get stuck on, you can look at the answers. They are there in this folder, as well as sending me an email if you feel like you're really stuck on a particular question. Thanks, and I will join you in a second with the next set.